This is another example where we're trying to determine whether or not an equation is balanced. Here's the equation. 6CO2 plus 6H2O make C6H12O6 and 6O2. Now once again, we'll split the screen in half. The left side of the screen will represent all of the atoms on the reactant side of the equation. The right side of the screen will represent all of the atoms on the product side of the equation. Let's start with the first atom we see. The first atom we see is carbon. In CO2, there's one carbon atom because there's no subscript after the C. However, there are 6 CO2 molecules. So I have to take the number of carbon atoms in the molecule, 1, and multiply by the number of molecules, 6, and I find out that there are 6 carbon atoms on the reactant side of the equation. If I move to the product side of the equation, the carbon atoms are in the molecule C6H12O6. The subscript of 6 next to the carbon means there are 6 carbon atoms in every molecule. There's no number to the left of the molecule, so that tells us there's only one molecule of C6H12O6 in the equation. So I take the number of carbon atoms in the molecule, 6, multiply by the number of molecules, 1, and I find that there are 6 carbon atoms on the product side of the equation. All right. Well, the carbon atoms match. There are 6 on the reactant side, 6 on the product side. So those atoms balance. Let's move on to the next atom. The next atom is oxygen. If I look at the reactant side, I actually see oxygen in 2 molecules. Oxygen is in CO2 and it's in H2O, so I have to take into account both molecules. We've got to do it one at a time, though, so let's start with CO2. In CO2, there are 2 oxygen atoms in every molecule. That's what the subscript 2 means. However, on the left-hand side, there is a 6. So that means there are 6 molecules of CO2. So to get the total number of oxygen atoms here, I got to take the number of oxygen atoms in the molecule, 2, and multiply by the number of molecules, 6. That gives me 12. I'm only halfway done, though, because oxygen also appears in water. So I have to count the number of oxygen atoms there as well. There's no subscript after the oxygen atom, so that means there's just one oxygen atom in every molecule of water, but there are 6 molecules of water. So the number of oxygen atoms in a molecule, 1. The number of molecules, 6. The total number of oxygen atoms from water, 6. Now, how many oxygen atoms are total on the reactant side of the equation? Well, I got 12 coming from CO2, and I got 6 coming from water. So the total number of oxygen atoms on the reactant side of the equation is 18. All right, let's move to the product side of the equation. On the product side of the equation, oxygen appears in 2 molecules as well. It appears in C6H12O6, but it also appears in O2. I have to deal with them separately, though, so let's start with C6H12O6. That subscript of 6 means there are 6 oxygen atoms in a molecule. There's no number to the left of the molecule, so that means there's only one molecule in the equation. So the total number of oxygen atoms coming from C6H12O6 is 6, the number of oxygen atoms in the molecule, times 1, the number of molecules in the equation, or 6. How many oxygens come from O2? Well, the 2 means there are 2 oxygen atoms in every molecule. The 6 that's written out to the left means there are a total of 6 molecules. So the total number of oxygen atoms coming from O2 is 2 times 6, or 12. Now the total number of oxygen atoms on the product side of the equation comes when I sum up all of these atoms. I got 6 coming from C6H12O6 and 12 coming from O2. The sum is 18. Well, that's a match. There are 18 oxygen atoms on the reactant side of the equation and 18 oxygen atoms on the product side of the equation, so the oxygen atoms are also balanced. Well, there's only one more atom to consider, hydrogen. Hydrogen appears once on the reactant side of the equation. It appears in H2O. The subscript 2 means that in every molecule there are 2 hydrogen atoms. However, the 6 written out to the left of the molecule indicates that there are a total of 6 water molecules. So the total number of hydrogen atoms on the reactant side of the equation is 2, the number of hydrogen atoms in a molecule, times 6, the total number of molecules, or 12. So there are 12 hydrogen atoms on the reactant side of the equation. On the product side of the equation, hydrogen also only appears once. It appears in C6H12O6. The subscript 12 means there are 12 hydrogen atoms in one molecule of C6H12O6. We only have one molecule in the equation because there's nothing written to the left of the molecule. So the total number of hydrogen atoms on the product side is 12 times 1, or 12. That's also a match. There are 12 hydrogen atoms on each side of the equation. So the hydrogen atoms also balance, and as a result, this entire equation is balanced because every atom balances. All right, I want to make two quick points here. First of all, understand that every type of atom has to be balanced in order for an equation to be balanced. If even one type of atom were not balanced, this entire equation would not be balanced. The other thing to realize is this is not some mindless exercise. Balancing equations is one of the most important things in chemistry. It's important for two reasons. First, it's important because of the physical situation. The reason we balance chemical equations is we can't create or destroy atoms in a chemical equation. So if, for example, a chemical equation had 6 carbon atoms on one side, but only 4 carbon atoms on the other side, that would imply that as a part of the chemical reaction, 2 carbon atoms disappeared. That's impossible. So that's one reason balancing chemical equations are important. If you don't balance the chemical equation, the physical situation is not represented properly. The other reason is probably even more important. Balancing chemical equations is the first step on the road to a wonderful subject called stoichiometry, which you're going to learn about in a couple of modules. If you can't balance chemical equations, you will never, ever, ever be able to do stoichiometry. Stoichiometry requires a balanced chemical equation to start out with. So you've got to master this technique, or you're going to be completely lost when you get to Module 6.